The broadcast is now starting. All attendees are in listen-only mode.
Hello, everyone. I'm Rob Meyer. I'm going to be your GridGain host today. We're going to get started right now, and before I introduce the main speaker and we get into the details, wanted to make sure that you can all hear me, and also that everything seems to be working with the webinar. So if you can just raise your hand using the hand icon in the GoToMeeting panel, that would be great. And I see some hands going up, so I'm going to assume we're starting to work here. Yeah, it's just the, you should be able to see a hand panel. But in any case, feel free to type out questions at any time. During the session, I'm going to save the hardest ones for last for Ivan, because that's what I do. But you're going to be on mute during the webinar, so your main way of communicating is by typing in the questions section, and I'll try to answer some along the way, but save some for the end. Now, just a brief introduction to today's webinar, which is about best practices in cluster topology management and data replication, basically setting up your distributed cluster. This is being presented by Ivan Rakov. Ivan is one of the Ignite contributors. In particular, he does a lot around this area with Apache Ignite. He is also an architect here at GridGain. So for those of you who aren't familiar with GridGain, we're the company that originally contributed the code, and several folks within GridGain continue to actively contribute to the project. We happen still to be the leading contributor, though a lot of other great folks contributing to the project as well. With that said, I think, Ivan, I'm just going to hand it off and we can get started.
Okay, thank you, Rob. I hope everyone can hear me. My name is Ivan Rakov, and I'm, as Rob said, I'm an Apache Ignite committer and software engineer in GridGain systems. My area of influence and expertise are crash recovery and native persistence. So I'll tell you today about how to manage your cluster on the example, and I'll use Ignite as an example. So let's get started. Let's start with the distributed systems and how they can help us. If you have too many data and your data doesn't fit good into regular database, you can start a distributed system. And what will you gain? You'll gain horizontal scale at a lower cost. That means if your amount of data will rise and your amount of requests will grow, you can just add new nodes to your cluster, and this load will scale fine on the set of the nodes. This is good, but this approach gives us some new challenges. For example, how to partition the data between the nodes, how to determine on which node exactly the data will be stored, how to start and how to deploy your cluster properly, and the other hot question is how to change topology of already deployed cluster. What should I do to grow or shrink cluster and don't lose any data? I'll tell you some best practices today, how to do this on the example of Ignite. So here's agenda of today's webinar. I'll tell a bit words about in-memory cluster management, and the most of my webinar will be devoted to the persistent cluster management, which is a bit more difficult. The key word for the persistent cluster management and is baseline topology. This is concept that was introduced in Ignite 2.4. And I'll tell you why we need such thing, and finally, what is it? And I'll tell you how to manage it with API, and we'll we'll consider some use cases, how to do some things, including growing and shrinking cluster with help of baseline topology. And at last, we'll consider, I'll drop a few words about split brain. I'll tell you what it is, I'll tell you why it's really bad in distributed systems, and I'll tell you how, with the help of baseline topology and Zookeeper, which is a recent feature of Apache Ignite, you can handle it. Okay, let's start with the in-memory cluster management and data replication. When you start Ignite cluster, the main approach for not losing your data if something bad will happen. For example, if one node leave is replication. You can configure. It's very easy to be done in Ignite. You can just configure amounts of backups and partitions. Data is actually stored in Ignite in partitions. And if you, for example, set 1, that means for every partition there will be one more replica in cluster. So if you will lose any nodes, you will not lose your data. So let's consider this example. Here are 4 nodes and 8 partitions in total. And for every partition, there's another copy on the another node. Let's consider a scenario when one node crashes or leaves for some reason. What's going on? You still have all your data in cluster, but because all your partitions are replicated. But in this case, some partitions become in danger. As you can see, 4 partitions now have only 1 replica in the cluster. I've marked such partitions with red squares. That means if another node will leave, you will lose your data for sure. And Ignite manages this situation automatically in memory mode. What happens here? Affinity function reassigns partitions to the new hosts, and data rebalancing started. The data rebalancing is started. That means that I'm sorry. I think I have to shut down my messenger. I should have done that before. And okay, we are set now. Well, data is automatically rebalanced and everything is good, and backup factor is recovered. So in case you will lose any another node, nothing bad will happen and you will not lose your data. Well, there is a restriction that you should have necessary amount of space on your nodes to make such rebalancing possible. Okay, it's quite simple, and let's cover use cases that I mentioned before. You want to deploy cluster in memory mode. You have just to start necessary amount of nodes and fill them with data. You want to scale and expand topology. You should just start new nodes, and data will be rebalanced among new set of nodes. You want to shrink your topology. You can just remove the nodes, but not all at once. You can remove only backup factor node at one step, because, for example, if you will remove 2 nodes here, you will lose any partition certainly. So you can just set bigger backup factor to shrink your cluster in a faster pace. So your data will be automatically rebalanced over the new set of nodes in any case. Well, if you remember, I mentioned some challenges. And where is the challenge here? It's quite simple to do this in memory mode. So let's consider a persistent cluster management and get started with baseline topology and meet the real challenges. So in persistent mode, when node leaves, backups are still present on drives. So the data on the offline node is in kind of Schrödinger state. Yeah, it's not present in cluster right now, but it's still not lost. And there's a question: if data is not lost, do we really need to trigger rebalance immediately? Do we really need to do this, or we can just wait until the node will leave and all persistent data will be still available? To answer that question, we should consider and estimate rebalance time. How much does it actually take to transfer all data and all partitions to their new homes? I can say it certainly depends on your network bandwidth, on amount of data on every node, and on total number of nodes. But I can say for sure that it's a lot of time. You should transfer all the partitions that were dropped at the left nodes through the single network switch, for example. And you can't do that faster. That it's then such amount of data is physically able to be transferred through that switch. So it's a lot of time when node leaves, and it's nearly the same amount when node returns. In persistent modes, it's still a lot of time, but much more than in memory-only mode. Much more, well, I put an asterisk here, and that's why. Firstly, usually there's much more data on nodes if you use persistence. Usually when you use persistence, it's because you can't fit all your data in RAM. The other reason why rebalancing in persistent mode is slower, that you have to, or you don't only need to have to rebalance all your data, but you also have to persist all arrived data to the disk to write it into the write-ahead log and to do the checkpoint. It's clearly the same amount if node will return after long delay or with the clear local file storage. You still have to rebalance all data on that node. But in persistent mode, there's one difference. If node returns after short delay, rebalance will be much quicker because only diff will be transferred. We have such thing as write-ahead log when we use persistent mode, and we can just replay write-ahead log on the alive nodes and transfer to new nodes on the delta for the time that node actually were missing. So if node were missing for example, 20 minutes and there were only a little amount of updates, the rebalancing will be nearly instant. You will only have to transfer the little delta. So should we panic after all if node leaves in persistent mode, or maybe we should hold rebalancing for a while? Here comes the baseline topology. Baseline topology is an instrument for holding rebalancing for a while. Let's quickly define the baseline topology in formal matters. Let's define three sets. Current online server nodes are online, temporarily unavailable server nodes are offline, and set of nodes that we fixed and remember whatever happens is baseline. So the idea of baseline is to fix and remember some set of server nodes. So without baseline topology, what's the difference? Without baseline topology, affinity is calculated by online set, and that means that partitions, affinity includes a function that maps partition to actual node. That means that partition will reside only on online node set. But with baseline topology, affinity is calculated by baseline set, and partitions will reside on baseline subtract offline node set. What does it mean? That if any nodes will be added to the topology or removed, there will be no rebalancing if unless we will manually change the baseline. So let's view it on the example. So it's previous example, but with the persistent mode enabled. We activated the cluster, baseline topology is established, and it is created from the whole set of online server nodes. For example, if one node will leave, we won't transfer data to anywhere and won't reassign partitions. Since partitions are mapped to nodes by the baseline topology, baseline is still the same and partitions are not reassigned. The same situation happens when new nodes join the topology. Baseline topology is still the same and still nothing happens. Well, it's quite obvious that baseline topology doesn't prevent us from data loss, because if such situation may happen, with backup factor 1, 2 nodes may leave at the same time. In such case, even though baseline is 1, 2, 3, 4, we only have 2 nodes, 2 and 1, in the actual underlying set. That means if we, for some reason, want to access key in partition number 6, we can't do that because it's lost. The question is, if there were no baseline topology and we would start rebalancing immediately, would that save us? That depends on the time of the rebalancing and time of the node absence. If the gap between node 4 left event and node 3 left event were small enough, rebalancing couldn't have completed in that gap. So if we would have started rebalancing immediately, that wouldn't have changed the situation. The data will be still lost. So there's a rule of thumb for administrators here. If node isn't expected to be back soon, then you change baseline topology manually. So if it's just a regular crash and you just able to restart the node immediately, you don't have to do anything, and you won't affect your cluster by rebalancing. But if you understand that your node, for example, is offline for the long period, for example, disk device is out of service for some reason, then you have to change baseline topology to reassign the partitions and restore the backup factor. Okay, let's talk about how you can and how you should change and affect the baseline topology with API. First of all, unlike in-memory mods, persistent cluster should be activated manually at the first time. There are some reasons for that. One of the reasons that the rebalancing is really slow, and a cluster will be assembled for a long time if you will assemble it from active nodes. And anyway, unlike in memory, persistent cluster should be activated, and if you start and activate cluster with clear local file storage when there is still no data, and you do the activation, first activation establishes baseline topology, and baseline topology is persisted. That means if you will restart that cluster later, baseline topology will persist. It's persisted in local file storage in special metastore partition that we use for several things. Once your cluster is up and running and baseline topology is set, you may want to change your baseline topology. For example, for the cases we've discussed a bit earlier. If you want to grow or shrink your topology or something, you can just call method set baseline topology and pass here a topology version. Topology version is just a lon, and it easily can be extracted from logs, and it can be extracted from Control-sh script. If you run Control-sh, it will show current topology version. So that method call sets current node set as baseline if topology version is still equal to the version you passed. It works like compare and set operation. Yeah, you just compare topology version that you passed with actual topology version and change the baseline if they are really equal. There's an option for more precise configuring of baseline topology. You can just pass a set of baseline nodes. Baseline node is just abstraction. It has 2 implementations as far as I remember. First implementation is just regular cluster node. So if you call Ignite cluster server nodes or something like that, it will return a collection of cluster nodes. So you can pick the cluster nodes from the collection that you want. Or you can construct a tuple, a detached node, from your own parameters. You may pass consistent ID and any node attributes if you want more precise filtering, and pass that detached node to the set baseline topology method. With the hack, for example, you may add nodes to baseline if they are still offline. For example, you will know that new server will be shipped to your data center tomorrow, but you can still change the baseline and add the server even today. Okay, and the bonus that comes with baseline topology is automatic activation. Without baseline, you had to activate your cluster manually on every start and every start in persistent mode. With baseline, it's not necessary anymore. You have to activate a cluster only in first time, and then cluster will be activated automatically when baseline is reached. Baseline is reached means that all nodes from persisted baseline topology are present in a set of online server nodes. It's especially handy when you use Ignite in embedded mode. So you have to only implement, only activate it once, and then if you want to restart it, you just have to restart it and it will be active without any manual actions. Well, it's quite handy, and we'll talk a bit about it later. Yeah, we'll talk about it as one of use cases, and now let's discuss popular use cases of managing persistent cluster with baseline topology. The first use case, we discussed it a bit earlier, is first cluster activation. To achieve this with the persistent cluster, you have your first action is starting necessary number of nodes. You can do this via Java API or with Ignite SH control script. When you do this, cluster is inactive and can process user requests, and baseline topology is not defined yet. Then you activate the cluster, for example, with control sh -- activate. This action will set current set of online server nodes as baseline topology, and it will make cluster active and capable of user requests. Next use case is cluster restart. If you have a running cluster and you want to shut down and do something, any kind of maintenance, for example, update your business code, you have to deactivate the cluster first. It's the safest scenario because stopping nodes one by one may turn your cluster into undefined condition. So some partitions may be lost until all nodes will be stopped, and it's not good. So the safest option is to deactivate the cluster first with the same control script, for example. Stop all the nodes, do the necessary maintenance, add new jars, or change some hardware, anything. And then you should just start all nodes back. Cluster, as we said, will be activated automatically. Last BLT node joins the cluster. And if some BLT nodes are unavailable for some reason, for example, you can just launch your server because it's broken, but you want to get your service up and running, you still can activate your cluster manually with control sh -- activate, but you have to remember that BLT will remain the same after this action, and therefore the backup factor will be decreased. If you understand that nodes, the missing node can't be started very soon, you have to change your baseline topology to start the rebalancing and return backup factor to the normal state. Another use case is expanding topology. If your business grows, you just can start new nodes, add them to the baseline topology with one of the following ways. And after you call baseline change, data will be rebalanced over the new set of nodes. Well, it's quite simple. If you want to shrink your topology, again, you have to stop nodes that should be removed. But if you want to stop a large amount of nodes, you can do that. You should stop only backup factor nodes at once, because if your backup factor is 3 and you will stop 5 nodes at once, you may reach in the situation when you will stop all nodes with the certain partition, and that partition will be lost. So the safest way is to stop nodes one by one, but you can do it faster if your backup factor is bigger. Okay, after you stopped the batch of nodes, you should just remove nodes from the baseline topology with one of the following ways, and then data will be rebalanced over the new set of nodes. And the last but not least use case is very actual, and some users complained about it, and I have to agree with them. Before 2.4 release, it was quite very simple to manage persistent cluster. Rebalancing was triggered automatically. Now you have to change baseline topology. Of course, there are reasons for that. We have discussed it. But if for some reason you want to change, you still want to change your baseline topology automatically, you can do that. The most straightforward way is to write your own code. It's quite simple. It's nearly 10 lines. You can check this section on the Apache Ignite README.io on the link, and I can just show you what actually happens in that code. I'll toggle now presentation mode, and we'll cover what happens. So to change baseline topology automatically on one of your several nodes, you have to. So one of the possible implementations is just subscribe to local events, and you can use Ignite events local listen for that, and pass not failed, not left, and not joined events as events that you are listening to. These 3 events are the only events, are the only discovery events, we call them that way, that can appear if topology is changed. So the code is quite simple. Once topology was changed, node added or node left, you just gather all live server nodes, you pick the baseline topology, and you just compare a live server node set with baseline topology. If they are not equals, you just add timeout object. That means that the such action will be executed after certain timeouts. So in example, it's 60,000 milliseconds, which is 1 minute. So this code will guarantee that if topology is changed, that your baseline will be changed in 1 minute. There's a trick with topology version that allows us to don't change baseline many times if there are a chain of not failed or not left events or not joined. So if there are many events at one time, you will just wait until the last of these events, until the 1 minute will pass from the last of these events. At that moment, you will actually change your baseline topology. So it's just one of the approaches. You can write your own or modify that one. I agree that it will be much more convenient to change baseline topology just with Ignite configuration, and we are planning to do that. We're planning to add baseline auto change policy, and it's expected in 2.7 Apache Ignite release. Okay, we reached the split brain section. Okay, what is split brain? Split brain is condition when your cluster, or when for some reasons, usually it's network reasons, your cluster gets splitted into 2 independent parts, and each part thinks that it's the only one part. Well, Apache Ignite as a system that is much more for precise computations, for transaction processing and so on, there's a CAP theorem, as you can remember, and there are CP and AP systems. And Ignite is much more CP system than AP. And the only reliable way to build CP system with Ignite is shutting down all subclusters if split brain occurred except one. Otherwise, if you won't do that, consistency will be sacrificed during merge of conflicting updates. So if split brain happens, you have to determine the leading cluster, and for all clusters, you have to shut them down or to block the updates. Well, let's talk about how you can achieve this in Ignite. There's such interface as Topology Validator. It's an interface, so you have to implement it, but related to your own infrastructure, related to your own deployment. These implementations may differ. And Topology Validator is a code that will tell, in case of split brain, whether or not this part of subcluster should be shut down. So let's consider this example. There's a split brain and a cluster is split into two clusters. There's a big guy and tiny guy. And Topology Validator comes and he have to decide which part of the cluster should have been killed. And if you will implement the Topology Validator correctly, it will tell one of the subcluster to die. It will consider all the consequences, and for example, it decided that tiny guy should shut down. Then tiny guy shuts down, and the code of Topology Validator is over. Well, basically, Topology Validator is an interface which contains one method, validate, and accepts set of nodes as the argument. So Topology Validator said that tiny guy should have been shut down, and then a big guy operates in the usual manner. It accepts updates, and tiny guy is just fine. Topology Validator disappeared. He has done all his job. But then what may happen next? Then for some kind of error or for some kind of administration reason, tiny guy, which is dead, may be revived. And if tiny guy is revived, it may accept updates. And these updates may conflict with the updates that come to big guy, because there may be repeating keys. Yeah, if you have configured your affinity function properly, there may be even no lost partitions, and for every key there's a copy in left cluster and copy in right cluster. And in such situation, we are messed up. There is no way to merge these two subclusters if the connection will be restored without any conflicts and updates. The good point is that, that's the picture for that. So if there are conflicting updates in that part and in that part too, and there will be mess after attempt to merge these two subclusters. The good point that Topology helps us to prevent such situation, and it has the algorithm which will prevent this evil subcluster with conflicting updates to merge with a good subcluster. We do the following trick to achieve this. On every event, like cluster activation or baseline change, we append a hash from current set of baseline nodes to the head of the hash chain. So on every node, there's a hash chain of all which contain hashes of all baseline topology in history. So there's a simple rule. If a node joins cluster, if head of the hash chain if node joins cluster, if head of chain of joining node is not contained in the whole hash chain of the cluster, such join is rejected. Well, so there's a rule of thumb. After split, leaving subcluster should be started first, and the part that was idle should join. Well, if that is not accomplished, you may see an exception like that. Well, that may sound messy, so I will describe this on example. So consider the following history of the cluster. Imagine that cluster is activated, and then imagine that baseline of the cluster is changed. Now the history, when the cluster is activated, the history of the hash chain contains only one hash, and imagine that it's a. Then baseline is changed, and we record such events at the head of hash chain on the all nodes, and all nodes in that cluster contain history h1, h2. Then imagine that split brain happens, and imagine that cluster is split into two clusters, and imagine that right cluster have been shut down by the topology validator, but for some kind of error or administrative error or something else, it's appeared again and leaving and accepting updates. If such event will happen, new hash chain will be written to its history. So history of the evil cluster will now have H3 as head. Then if the network connection will reappear and we will join try to join evil cluster to the good one, its merge will be rejected because head of the hash chain H3, so here actually should have been H3, not H4, because H3 is not contained into the hash chain of the living cluster. So such merge will be rejected, and you will see the following message. It's good that such merge is rejected, because such merge can't make situation any better. Such merge can only bring conflicting updates. Let's consider the another scenario when smallest cluster was shut down by the topology validator, and it was idle through the time. It wasn't activated. It's expected behavior, and in case of such behavior, even if there is a new event in the living cluster, attempt to rejoin the cluster after the connection is restored will be successful, because head of the chain on the dead cluster is contained in the chain of the alive cluster. So here is how it works, and we hope that it will save your production one day. Well, except topology validator, there's another option to save your cluster from a split brain. Since Apache Ignite 2.5, we have Zookeeper Discovery SPI. It's an equivalent for TCP Discovery SPI, which is default for Ignite, and Zookeeper is actual. So why we have introduced the Zookeeper SPI? Because TCP Discovery SPI didn't work really well on the really big clusters. If there are hundreds or even thousands nodes in your cluster, the message will have to pass all the ring to notify all nodes. So we use walkthrough by the ring for system events like change or topology change. And that complicates the work with cluster. So that's why we implemented another SPI, which uses Apache Zookeeper. And Apache Zookeeper manages all the nodes. And if nodes want to discover each other or send any kind of system events, they ask Zookeeper to do it, and Zookeeper do the job. So imagine that. Here's a sketch of connectivity and topology of Zookeeper cluster. Nodes are still connected between each other, and there's Zookeeper who manages and watches all the nodes. So imagine that for some reason there are two cases. Actually, let's start with first case. And in first case, we have intracluster peer-to-peer communication loss. So it may happen if there are two data centers and link between two data centers is broken. But for some lucky reason, clusters still have connection to the Zookeeper. Zookeeper will be immediately notified about connectivity problems, and he will decide which cluster should die. Zookeeper will calculate largest fully connected subcluster and kill all the other clusters. Calculating largest fully connected subcluster is actually NP complete problem, but we use an approximations that works in all usual cases. We tried it. So if there's such thing as link broken between data centers, this approximation will work. Zookeeper will determine the smallest clusters, cluster or clusters if there are several subclusters, and kill them all. So Zookeeper will send unnecessary clusters offline, and split brain situations will be prevented. So there may be no conflicting updates on the smallest subcluster because Zookeeper have shut down it immediately. So consistency violation is prevented, and we still have a CP system in the notation of capped theorem. The another case is total subcluster isolation. Imagine that not only link between two subclusters is broken, but all the connection with external world is broken for one of the subclusters. The following thing will happen. Zookeeper will immediately be notified about it because he won't be able to send any kind of messages to the tiny cluster. And then Zookeeper will just exclude that unavailable cluster from the set of the working nodes. The feature is that node in unavailable subcluster will not be able to discover each other because in the mode when Zookeeper discovery SPI is used, they use a Zookeeper for that stuff. So if a connection to Zookeeper is unavailable, then nodes are not cluster anymore. They are just single nodes. Yes, and they just getting shut down. So in such case, that isolated subcluster that is unavailable to Zookeeper will be shut down immediately as well. And there will be still no any problem with conflicting updates. So to sum it up, if you want to be protected from split brain, you can either implement a topology validator, which will tell which subcluster should be dead, should be killed, or use Zookeeper discovery SPI. That will help if, but this requires a more complex infrastructure. You don't have to only host your cluster, but you have to host Zookeeper somehow. I think that's it. So thank you for your attention. If you have any questions, please ask, and Rob will tell out these questions for me, and I will answer.
Great. Well, we've already been getting a few questions. So actually, there were a couple around Kubernetes. So the first one was, how do I use baseline topology and clustering and replication in general with Kubernetes? What are your recommendations for that? And I should preface this by saying we're also going to do a two-part series, I think, on Kubernetes soon. So we may be able to work some of those answers in there. But I was wondering what your response is right now.
Well, to be honest, I'm not really familiar with Kubernetes, but I think the main approach will work fine here. The only thing that you should be aware of is the first activation of cluster. So if your cluster will be activated firstly, then if anything will happen and cluster will be shut down, it will be activated again automatically. I think it's a good point for asking on the user list, and Dennis Magda will provide some clarification on this question.
Yeah, so in terms of the user list, there are two. If you go to ignite.apacheignore.org, you've got the Apache Ignite user list, which you can reach just by clicking at the top of ignite.apache.org. There's also Stack Overflow. Both get used but and both get washed by Dennis, by Val, Ivan watches as well. So you'll probably get a pretty good answer. And the more questions you ask about something like Kubernetes, the more we can actually feed it into the webinar. So ask away. I'm going to leave the second question because it was about pods. I'm going to assume you don't know the best practices about pods, but maybe you do. How do clusters relate to pods? How you cluster basically all the containers on the same node. I think that's a pod.
Okay. Once again, please. When you have several nodes on the same physical machine, is that the question?
I think so, but I think it's how are you working with the baseline topology relative to pods, and I think we can get that one on the Ignite user list as well if you want.
Well, I think nothing changes here again. So all you have to do, this doesn't, the features, how to manage the baseline topology doesn't actually depend on your actual deployment and where your cluster is stored. All you have to do is to call necessary methods on the API. Well, it's not really a lot of them, and I think it should be quite simple.
Yeah, so let me ask you a related question, because I think this has to do with bringing them up and taking them down. What are your recommendations for setting up the replication and the scaling up and scaling down to make it easier to scale up and scale down? Because there's this issue with how fast you bring them up and bring them down, especially bring them down, and put rebalancing, and do that alongside rebalancing as you're bringing them down.
Well, the question was about backup, as far as I understood.
Yeah, it's the replication copies. As you bring a node down, you might be you might be putting some partitions at risk. So what are your recommendations for doing, taking a node down, letting it rebalance or not, taking another node down? What are some of the tips and tricks there what would you summarize there for the best practices?
Well, it actually depends on your on how you measure how risky your network is, and on the backup factor you can afford. So the bigger backup factor is, the more space you need to store all the data. Some of our customers use backup factor 3. That means every replica is stored in 4 copies. And the usual approach for it is shutting down nodes by 2. So you should just shut down 2 nodes, and for every partitions, there are still 2 copies. So if something bad will happen and 1 more node will be dead, then it's still okay, and there will still be at least 1 copy. Well, we were discussing about that. It's not actually the most convenient way to shrink your cluster, and it would be more convenient to just set baseline topology to the subset of your nodes, and just after that will happen, just kick in the redundant nodes. But right now it's not kicking online nodes from baseline topology is not available for some reasons. You can just kick offline nodes. I think we will implement that feature in 2.7 as well. And about now, you can just use your backup factor -1 and kill nodes in batches.
Okay.
It will work. Yes.
Okay. Very specific questions. The event nodes, the event node events, like event node left. Is that guaranteed delivery? Can it be duplicated? Meaning, can you have duplicate events? What's the at least once, exact once, at most once delivery?
Okay. I think I got the question. Yes. We have guarantees for discovery events that they will arrive exactly once on one exchange. So we have on one topology change, I wanted to say. And more important, they will pass through nodes in the specific order, or nodes are forming ring. That's how our topology works. And every event will pass through every node in exactly same order. So that is our internal feature that allows us to implement distributed algorithms and make them consistent.
Okay, so it's exact once and ordered.
Yes, exactly once and ordered.
Okay.
Order is the same.
Okay. For a okay, I think actually there were some questions about rebalancing when nodes aren't going up and down. So what are some of the reasons why rebalancing might suddenly happen when the nodes aren't changing, meaning it's the same number of nodes? What could be causing periodic rebalancing or delayed rebalancing in people's cluster configuration? So this is more troubleshooting. What are some of the things that you've seen that can happen?
Well, usually the main reason, and I think the only one reason for rebalancing, is topology change. Yeah, so affinity distributes partitions in a stable manner, so they won't be moved to another nodes for any reason. And if your node will live in memory mode, there will be a rebalancing. And if node will reappear in memory mode, there will be a reverse rebalancing. So in persistent modes, situation is a bit different. There will be no rebalancing if node leaves. So this picture is irrelevant. I think this is more relevant. And if this node will reappear, there will be rebalancing of the diffs, of the deltas to that node. So if you observe rebalancing, if your topology is stable, I think that's strange, and I think it's worth investigating.
Mm-hmm. And is there a possibility that rebalancing is happening because of various load balancing, or is that possible, where the basically partitions are shifting around to handle the load in different ways, or not?
That shouldn't happen. The partitions should travel among the cluster unless the topology is changed. You can't change affinity function in online manner. So if there's a rebalancing, there must be a connected topology change event, and it's
okay.
one operation.
In terms of practical recommendations, there's one question here: is it best practice to have an odd number of nodes? It's an interesting question. What are your recommendations for having a certain number of replicas of copies? Is it 1, 2, 3? What are sort of your rule of thumb recommendations here to make things easy?
Well, first of all, you have to consider how much servers and how much place you can afford. But I think you shouldn't run with 0 backups. But 1 backups is okay situation if you. But it depends. So you can imagine if you will lose 2 nodes, then 1 backup will not save you. So, but losing 2 nodes is a really rare event, and losing one node may happen for some reason in practice. So I think if you really don't want to lose your data, but it will be not a disaster if you will do it, you can just set 1 backup. But if you want more strict guarantees, you can just it would be better to set at least 3 backups. Yeah, if you have 3 backups, 3 nodes may leave, and it's really coincidence of different consequences of different conditions that the 4 nodes, if the 4 nodes will crash in the same amount of time. So I think 1 or 3 backups is a rule of thumb.
Okay. All right. Well, listen, I want to thank you, Ivan, for all the tips and tricks. Clustering and topology management is never easy. So thanks for making it easier, first of all. And second, if you have any other questions, feel free to go to the Ignite user group on ignite.apache.org, top of the webpage. You can just click and start submitting, because a lot of the contributors and Dennis is the PMC chair, and others, including Ivan, are watching and answering questions and learning. So feel free to go there. For those who had Kubernetes questions, hopefully we'll get the invites out soon. We're thinking about a 2-part series, but if you have specific questions, again, put them up on the user list, because we're watching it, because it could help shape those webinars and the topics we cover as well. So with that, I want to thank everyone for attending, and looking forward to having you on the next webinar. So thank you.
Thank you, Rob, for hosting, and thank all for your attention.